Hi, everyone. Today I'm going to talk about section 5.1, chapter 5, math 110. So this session, we're going to talk about exponential functions. Okay, so exponential function in the general form is fx equal to a times bx. Let me use, oops, what happened? Oh, 1 second. Okay, so the general form is fx equal to a times bx. In here, a is any non-zero number, and then b is a positive real number. So I'm gonna say a not equal to 0, and b is a positive real number, so I'm gonna say greater than 0, and b cannot equal to 1, so b not equal to 1. All right. So a is the initial, okay, we call the initial or starting value of the function. So then what? 0a will be the vertical intercept or y-intercept. Yes, y-intercept. Right. So y-intercept is 0. Right. And b is the growth or decay. Sometimes it could be decay, it could be grow, and they call it b is grow or decay factor, or also someone call it base of the base of the exponential function. Okay. And the r is grow or decay rate, and r actually in the relationship between r and b is b equal to 1 plus r. So sometimes we can change from f of x equal to a times bx. You want to change the growth factor to become the growth rate. I mean, the factor become the rate. You can change it as f of x will be equal to a times with 1 plus r to power x, right? So you see that I have just changed b to be equal to 1 plus r. All right, so one more thing. When a greater than 0, what do we have? Okay, so I say when a greater than 0, you have to remember that. For r greater than 0, or if r is greater than 0, and or b is greater than 1, so I say like r in here is greater than 0, and b in here is greater than 1, right? Why I have r greater than 0? Because I know that b equals to 1 plus r. So so if I subtract both sides by 1, and I have r equals 0, r greater than 0. So then the function is grow, right? So this would give me grow function. Okay. And another case is if B is in between 0 and 1, right? Such as 0 0.2, 0 0.5, 1/2, something like that, right? Or if you substitute B equal to 1 plus R and then subtract for 1 both side, if I rewrite it like this, so 0, sorry, 0 greater, less than 1 plus R, right? And less than 1, right? I just change B become 1 plus R. And then if I subtract 1 by one side, I'm going to get, if I subtract each term in here, each inequality in here with 1, I will have R less than -1. Oops. And no, R greater than -1 and less than 0, right? So this case will give you, I'm sorry. Okay. So this case is will give you decay rate and decay factor. Okay, so let's move to the next page. Okay, so we have an example. Let's consider two companies, A and B. Company A has 100 stores and expand by opening 50 new stores a year, right? So its growth can be represented by the function AX equal to 100 plus 50x. All right. For the company B, it has 100 stores and expand by increasing the number of stores by 50%. 50% is actually 0.5, right? Each year, right? So this is like the rate. These are the rate, okay? Or I say R equal to 0.5, right? So its growth can be represented by Vx equal to 100 times 1 plus 0.5 x. Okay. So let's we complete the table below and grab both functions on the axis provided. So for year equal to 0, what happened with company A? You need to plug in 0 into the company A here. So I have like A0, what is that going to be? 100 plus 50 times 0 is 0. So it's going to be 100, right? So I put 100 here. Similarly, for B0, what do I have? It's going to be 100 times 1 plus with 0.5 to power 0. And everything powers 0 will be equal to 1. So that means what? 100 times 1, and that's equal to 100, right? See that? Okay. So that is the reason why, like at first, all both company A and B have 100 stock, right? 100 stock at first. So you start with 100 stock, right? So what about 1 year, right? I gotta say x equal this, x equal this, Let's go this and let's go this. Right. So if the k that's actually equal to 1 or 1 years. Okay. So let me change this. Okay. So you have a of 1. Now what? I have to change the x become 1. So 100 plus 50 times with 1, right? So that's going to be 100 plus 50, and that equals to 150. What about b? B will be b of 1 will be equal to 100 plus multiplied by 1 plus 0 over 1. And what happened with this number? I'm going to use my calculator and what do we have? So 100, 1 plus 0.5, 100, it's going to be 150. Okay, so still the same, right? You can know that this is like 100 times with 1.5, right? 1.5 to the power 1 is just 5, right? So that's going to be equal to 150. Oh, so this both give you 150. Okay. Okay. Now for the case 2, try to finish by the same method I have and see what do you have for the 2 and 3. Okay. So let me write down the answer for you instead of calculate step by step. For A, for community A, when x equal to 2, it's gonna be 200 because you have 100 plus 50 times 2 is 100 plus 100. And for the K, that's actually 2 for community B, you're gonna have 1.5 to power 2 and then multiplied by 100. Now there's different, I have 225, right? Okay, so for community, for 3 years, you have 100 plus 50 times 3 is going to be 250. Right? Okay, but for company B, you have 1.5 to power 3 and multiplied by 100, you will get 337.5. Right? So then now I will try to graph both function on the axis that provide here. So the blue one I'm gonna use for company A. Maybe I change the color a little bit. Let me use. Okay. Use black. Okay. So first one is 100, 100, 0 and 100. So both start here. Okay. And 1 comma 150. 150. So this one, right? And 200 and 250. Sorry, 200, right? 200 right? And then 3 is 3 is 250. So so this is exactly like a line. You see that? So let me use. I don't have a sketch a line. Try to use. Doesn't have a line, huh? Okay, that's fine. I try to sketch a line. Okay, so this is a line. AX. Okay, and let's use another color for company B. So company B also start at 100, 150, 150, and 225, 225. So 225 gonna be here, and then 337.5, 3 and up, 337.5. I'm gonna say around here. So this one, and I'm gonna clean this stuff. Uh-oh. Okay. Okay, so I have to draw. Black, black. This one. This is a line, okay? And this is exponent. Okay. And I say this is p of x. So you can see that at first, both of these functions were the same, almost the same, right? At first. But after that, b of x keeps going up very quick, right? And if you take a look at the function v of x and f, excuse me, and f x, you can see that the variable for b for the function bx is in the exponent of the function, right? So that is one thing that you can see the difference from the exponential function and non-exponential function. So this is exponential function. Right? Okay, and you see that the exponent right now having a variable which is okay. And okay, last we gonna move to the next page. Okay, so let's move down. Now we're gonna try to find the equation of an exponential function. So before we were given an exponential function, right, we then evaluate for a given input. sometimes we are given information about an exponential function without knowing the function explicitly, right? We must use the information to first write the form of the function, determine the constant a and b, and evaluate the function. For the linear function, if we given 2 points, we would begin by finding the slope. Then we would plug in the slope and a point to solve for the vertical intercept. For exponential function, the method is similar. Okay, but now let's follow 6 steps to find the equation of an exponential function. So that's given 2 points, right? So this will help you to find the equation of exponential function when you're given 2 points. If you want to see how can you apply these things into the homework, you can take a look at the homework, express homework in homework 5.1, or even in my in the assignment 5.1. I also ask you about find the formula for an exponential function that pass through the 2 point given. So in this problem, it's like 0, 5, and 4, 6, 4, 8, 0. So let's see how can we have idea to solve this problem, right? So let's come back with the trick here. So we're gonna remember that B will be equal to 1 plus R, right? And when in here R equals to the growth rate as a decimal, okay? So step number 1, determine the growth factor, which is determine with B, all right? So plug the factor into the formula y equal to a times bx. Okay. And then we're gonna plug a point into the same formula. So, okay. And we're gonna solve for the vertical intercept b. Okay. Rewrite the final answer as an equation of the form y equal to a times dfx. So make sure to use appropriate variables. Okay, look like this is not really clear. Okay, so let's see if down here we have an example. So we're gonna start to work it. All right. So given the 3 statements below, identify which represent exponential function, which represent exponential growth. All right. So the cost of living allowance, COLA for state employees increased salaries by 3.1% each year. Okay, so this in here 3.1%. That is the growth rate, right? Because it's called increase, right? So this should be growth rate, and the R in here should be 3.1%. We're gonna be 0.031, right? So so that is for column A. And also in here we had to identify which represent the exponential growth. So I'm gonna say it is exponential because it's talk about the rate in here, so then it should be exponential. All right. So when it have something like increase salary by a rate of some things, then you should you should consider that is exponential function. Okay, so column B, state employees can expect 300 raise each year they work for the state. Okay, so in here, you you are having like $300 raise each year. What does that mean? I mean, each year you're adding $300 more, right? So so that's mean like you adding constantly $300. So I'm gonna say 300 raise each year, right? So then I'm gonna say constant change, right? Constant, you adding constantly, so as constant change. So this should be linear, not an exponential function. Linear, you add things. Okay, let's move to the so linear, and I say I use other color. Here's exponential function. Here's linear. And tuition costs have increased increased by 2.8% each year. Okay, so so you again you will see here you are having like a rate. So the rate in here is 2.5%, 2.8% is so I said 2.8% would equal to 0.028. And again, this is gonna be exponential function. Right. Okay. So what the difference in the word for identify the exponential growth and linear growth? You can see that for the statement that have something like the increase by rate, like a percent or something like that. So you should understand that you should consider that is exponential function. Or in the other case, such as if it adding or if subtracting is like a constant changing every year, then or every time, then it should be a linear function. It should not be an exponential function. Okay, so we're done with this column. Okay, look like this column have the topic that finding the equation of the exponential function. Let's see down here. Okay, so problem number 3. Look at the two functions below that represent the balance in two different saving accounts. What is initial value of each? What is growth rate? What is growth factor? So I'm gonna, so initial value, right? Growth, where's my ink? Growth rate. and growth factor, and which account is going faster, right? And which account will have higher balance after 3 years? Okay. So for the initial value of h, so initial value, right, for 80. Okay. So I can say initial value for 80 is what is the initial value? It's going to be the 1000 over here, right? As a formula, f of x equal to a times b to power x. In here, you should know that a is initial value, right? So when you look back to the formula that the function of 80, the 1000 here is going to be a, right? So is a1 equal to 1000. And for b of t is going to be is a2 equal to 900, right? See that? That has to be the initial value easily. Okay, so now let's talk about the growth rate. So as I mentioned in the first page, growth rate gonna be b. No, b, but b equal to r plus 1, and r is a growth rate. So I'm gonna say growth rate, or maybe I'm gonna start with the growth factor first. Growth factor is b. So growth factor for a t is b1. That's gonna be equal to this guy. Sorry, 1.05. Right? And for function bt, that's gonna be b2 equal to 1.075. Uh-oh, where's my ink? Okay, so that is for growth factor. Okay, what about growth rate? Right? For a of t, so I may have to do the side work here. For b1 equal to r1 plus 1. It's going to be r1 plus 1 equal to 1.05, right? Okay, now you subtract 1 both hand side. You have r1 equal to 0.05. Okay, so I have is r1 equal to 0.05. Okay. What about B2? I'm gonna write or R2 plus 1 equal to 1.075. And then I subtract by 1 both hand side. Again, I will have R2 equal to 0.075, right? So you will have for BT is going to be 2 equal to 0.075. That is for the growth rate. Okay. So let's use other color. What else? Which account is growing faster? Okay. So I'm gonna say the better rate will be growing faster. Okay. You see that the R2 is greater than R1. Okay. And also in here, yeah, also, yeah, I would like to say, because R2 greater than R1, so then I may have to mention A also, and A1 comma A2 greater than 0, because that meet the requirement for the growing or decaying stuff. So so I just want to mention that mainly it's gonna R2 with R1. So so BT is growing faster. Right. Maybe I'm gonna put it down. Faster. Okay. And lastly, which account will have higher balance after 3 years? So easily you may have to try A3. What is that gonna be? You put 1,000. You time with 1.05 to power 3. What is that gonna be? And then you wanna try for B of 3 with 900 time with 1.075 to power 3, and what you're gonna get. So for use a calculator, you will have let me see. Okay, use a calculator. You should have okay. You should have let me see 1 second. All right, so you should have A of 3 will be 1157.625. 1157 0.625. So let's put down 1157.63. And for the B3, you will have 1118.07. 1118.07. Okay, so yeah, so I'm gonna say even though we know that the B function B is growing faster, but you can see that when you compare after 3 years, A function gonna have higher balance. So so account A gonna have higher balance. So right here, A has higher balance after 3 years. Okay, so let's move to the next page. Okay, so this is problem number 4. A population of 1,000 is decreasing 3% each year. We need to find the population in 30 years. Okay, so so in this problem, we need to talk about the population. Okay, so in here is talk about population and also talk about the decreasing rate is 3%, right? It means that you are having a rate, and this should be an exponential function. Okay, and you should have A, which is initial. Okay, so this is the initial one. Here's A, right? Initial amount is 1,000, right? And R in here is the rate with decreasing. So then I have negative 3% is 0.03. So in order to find B, you just follow the formula as 1 plus R, which equal to 1 plus with a negative 0.03, and you will have 0.97. Make sure. 1 minus 4, 0.03 can be 0.97. 97. So B is going to be equal to 0.97. And P of T going to be the function is follow the formula as A times B to power T. And in here A is 1,000 times B is 0.97 to power T. All right. So you are looking for the population in 30 years. So say in 30 year. Which mean what? Which mean you are having t equal to 30, right? And then you will have p of 30 going to be equal to 1000 multiplied by 0.97 to power 30. Okay, what do you have now? So use a calculator. Maybe this one is not an easy one. Let's see. 0.97 to power 30 times with 1000. And we have 401.007. So I will say 401. It's going to be 401. I'm going to say. So P of 30 will be equal to 401. Okay, so I would say after 30 years, the population will be 401. So yeah, after 30 years, the population is the 401. 401. Okay, and you can note that in here B, let's say A greater than 0, right? A was 1000, which is greater than 0. So I say A equal to 1000, which is greater than 0. And B in here equal to 0.97, which is less than, say, greater than 0 and less than 1. Greater than 0, less than 1. So for this case, you should know that the exponential should be in decay factor, right? So that's the reason why you have like a decreasing 3%, right? Okay. Let's move down. All right. So you can see that problem number 5, they're giving you 2 points. And we want to find the formula for exponential function passing through 0, 10, and 3, 7. All exponential function. In here, there's a hint that all exponential function are in the form a times b of x, with a not equal to 0, b greater than 0, and b not equal to 1. Okay, so you can follow this step for me, to me it's usually easy if you follow this way. I know that's from 6 step. when I read previous page, it could be a little bit tough to understanding. So I'm gonna say let the general form for this exponential function is y equal to a times bx e to the power x, b to the power x. Remember that every exponential function had to have this general form. So when you find any exponential function that's passing through 2 points, you must have this general form. The thing in here is we are looking for A and B to put it in, right? So what do we have? We are having 2 points from the given. So let's say step 1 gonna apply or plug point 0, 10 into the form above, right? What do we have? So in here that 0 is x, value of x, and the 10 is a value of y. So let me use x, y. So we have what y now become 10 equal to a, I don't know, just keep a and b, right? But x will be 0. Okay. So what do I have now? Easily gonna be left hand side be 10, right hand side gonna be equal to a, right? B gonna be to power 0 equal to 1. So that means what? That means I have a equal to 10 easily, right? In the case that you don't have b equal to 0, I mean you don't have like x equal to 0, and you cannot get rid of b, you may have like isolate one of them, maybe it's to a. You may isolate a and then have like a function, no, not like an equation of a in terms of b, something like that. And then later on, you're gonna plug in another equation. But let me show you the next one. So the next step is you're gonna plug the second point, right? What is the second point? 3, 7, right? Into the form or the general form above, right? What is that? Now I have 7 is y and 3 is x. So 7 is y equal to a times b to power 3 is x. Okay. Okay. Now we are having a equal to 10 already, right? Over here. Okay. So I will substitute a equal to 10. Substitute a equal to 10 into 7 equal to a times b to the power 3. You have 7 equal to 10 times b to the power 3. So what do you have now? You're going to have to divide by 10 both inside, and you will have b to the power 3 equal to 7 over 10. What is that going to be? 0.7? So now what you need to do is you want to make the exponent 3 here go away. So then you can have b, right? You're looking for b. Okay, so how can you do that? You may have to do the root with the index is 3, because this is the only way to cancel the exponent. Okay, to eliminate the power. So same when you do the left hand side with the cube root, you have to do the same thing cube root with the right hand side. So let's try cube root for 0.7 cube root. Then you're gonna have it's not a good number. It's gonna be 0.8879 something. So I may have to write as b equal to 0.8879. Okay, so you can also keep with an exactly value as b gonna be equal to maybe use as color equal to cube root of 0.7 here to make sure you're gonna have like a very accurate function, right? So I will have function of y be equal to a now is a times b over x, right? But a now is 10, right? And did I miss anything? Yeah. No, okay. Just want to make sure. So a now is 10, b is cube root 0.7, and then everything to power x. Okay, so that should be the function you need to it needs for the exponential function. So let me circle it for this. Okay, so this should be section 5.1, and yeah, that's it. I will stop now for this, and I'm going to talk about 5.2 later. Okay.